Welcome to the next session on Introduction to AI and ML using Python.
From yesterday's session, found out that the calculation which I made was with 14 data sets, but while editing, I believe that there is a one record which is missing, but that's not a problem. So let's calculate with this itself. Once we calculate, we'll see how this is playing an important role. Okay, so what we can do is, first of all, we have to understand that we are calculating the entropy. That means the measure of impurity or the measure of disorderness in the output, right? Entropy means measure of impurity, right? And that's what we are doing, because in the output we have no and yes both, right? So we are separating them out and we are calculating the information using the entropy formula, right? So this entropy is a measure of impurity, and that is what we are denoting with information. Okay, so now let's calculate the information for the output. Okay, we are calculating now information of the output using the same formula of entropy minus first probability of positive events. In this case it is positive. How many positives do we have? 8. Negatives 5. So probability of positive into logarithm of probability. So again, so and then for the negative events, can you calculate the value of x? Can you please quickly calculate the value of x? I also got the same value when I did it today morning. Okay, so what is the value for this now? Use the same formula here. We have the same formula here, right? So instead of I of 8, 5, we'll be calculating I of 2, 3. Second one is pretty straightforward because we have one of them is 0. So if I write here 4 by 4 plus 4, 0, which will be 4 by 4. Here also logarithm of 4 by 4, and log of 1 will always be 0. So for this it is straightforward. And on this side it will be 0 by 4. So anyways it will be 0, right? So here it is straightforward and it will be 0. That's the reason I directly incorporated 0 here. Can you calculate for the third one? So 0.3001. Okay. Now let's calculate the information of the age. Now let's calculate information of the age using this formula, because if you remember from yesterday we have this formula, right? So this is our information value, right? And so in fact this is the information value which we are calculating using entropy formula, and now the information is being calculated using information needed formula. Okay, so let's calculate information of age, because we have segregated into positive and negative events for the age, and then we have calculated it separately because entropy cannot be calculated in a direct shot, right? So for that, what we have done, for the age column we have found out different subsets, and then using positive and negative events we have calculated the each corresponding information or entropy. Now if you want to calculate the cumulative information of age, then how we should do, using this formula which I have shown you in the previous slide. So here it will be dj by d, right? So here d is 13, 8 plus 5, 13. dj is 2 plus 3, 5. Multiply by its corresponding information plus 4 plus 0 divided by 13, multiplying it by its corresponding information, and then plus 2 plus 2, 4, 4 by total 13 into corresponding its information. So now let's substitute those values here. So what will be the value of this? It's Pretty straightforward. Let's do it together then. So first one was minus 2 by 5 and the next one was minus 3 by 5, right? And then we have to calculate the logarithmic values, right? 2 by 5 comma basis Okay, so now, sorry, this is the probability value, so it should be positive. Let's write 0.4. What's happening with this? Let me change it. Okay. So now let's calculate this. Yes, base is 2. So what is the value which we are getting? 0.97. Okay. So I think we have calculated with base E, I believe then. 0.97 and then 2 by 4, 0.5 minus 1. Okay. So if right. So what we are getting is 1. Okay. So now let's substitute that here 0.97 and 1. Okay. Now let's calculate this value. 4 by 13, 5 by 13 into 0.97. So 5 by 13 into 0.97. 4 by 13. Okay. So did you also get the same value 0.68? Okay, great. So now these are the information values. Now if I want to calculate the information gain for the age, then that means that is which is called as, I'm writing it as gain of age, is information coming from the output minus information for corresponding age. So this value would be, am I right? This will be 0.281, right? Right. So now the importance of this is, see, first of all, this is the information gain. This is the gain value if I calculate for, similarly, if I calculate for income, student and credit rating, then it gives us the gain value for all the four features, right? It will give us the gain value for all the four features. Now, what is this gain signifying? Gain value for each feature. It tells that if, for example, the gain value of age is greater than the remaining three, then it tells that age is a feature which actually having a lot of information in it, which signifies your output. Do you understand this statement? That means out of four features, feature age or column age has the highest amount of information hidden, or highest amount of information there, which will influence your output. Or you can also tell in this way that your output has an information from age of 0.281, and if you calculate similarly for the remaining three columns, and then if you notice that age is the feature which has the highest gain value, that means your output is determined, or output is more influenced by your feature age. Did you understand this statement? Right. So it was pretty simple, right? So now what happens, you were asking, right, yesterday, where to stop. See, if you do early stop, and if you do not choose a right node, then there could be a chance that we are actually stopping our decision tree early without calculating. For example, let's imagine that age has the highest gain value from remaining three. Okay, and I've started my root node with, say, income, and let's say age is going at the bottom. If you are not doing this calculation of gain values, I've started with income as my root node, and the age is going at the bottom, and then we are stopping the decision tree at somewhere in the middle, due to we are compromising with the overfitting, between overfitting and the accuracy, right? Then in that case, we know that in some other way, we are actually stopping age also, right? But we know age has a lot of information in comparative to other features. So we cannot compromise with that feature because it has more information which is influencing your output. So yes, so just imagine we were doing this decision tree, right? We were creating some branches, right? Yesterday we were creating some branches out of different, we can start with age, we can start with income, we can start with student or credit rating, it's up to us. But in future, in this course, you will be doing coding, assuming that you got some accuracy, you will not be worried about overfitting and underfitting. But when you do advanced courses, you have to make sure that your results are neither overfitted nor underfitted, right? In that case, and decision tree is more prone towards overfitting. Why? Because we can keep creating the branches for each feature until and unless our final output is pure, right? In that way, what we are trying to do is we are trying to create more branches, very shallow tree, like lot of levels in the decision tree. So as I told, we have to stop in middle by compromising with the accuracy so that it doesn't overfit. Overfit in the sense we are trying to resolve every minute information from the data set at the training level, but not necessary that could be generalized to a test data set, right? So it will overfit the training data set, right? So that's the reason. And now we know that feature age has the highest information, right? So we cannot compromise with this column age. And if we do not start with age, let's say if you are starting with income and age is coming in between like intermediate nodes. And if we had to cut down our decision tree, unfortunately, we are also cutting down our intermediate level at age, right? And which is not the right way, because information has the highest gain available, and that is a most important feature in determining your output. So that's the reason we tell if we keep age as the root node, then it actually minimizes the overfitting issue of the decision tree. So now you understood, right? It's always important that we should not, because to make sure that our model is not overfitting, we might have to stop our decision tree in the middle, right? And if it stops in the middle with, for example, while resolving column age, then it's not a good thing, right? I'm just assuming that age has the highest information. So that's the reason the algorithm is built in such a way that the column or the feature which has the highest information should be kept at the on the topmost. That means on the root node. Now when you create two decision trees, let's say you have created one decision tree, say with income, and then student, and then credit rating, and then age. Okay, and then create the decision tree based on the information gain. Then you will notice the decision tree is not shallowing as much as it was shallowing when you have not done this calculation. Okay, see, I cannot, the problem is we have to draw two decision tree now. Okay, that you have to do it on pen and paper. So what you can do is calculate the gain value. We have calculated for age, calculate the gain value for income, for student, and for credit rating. Okay, now based on the gain value, highest gain value should be at the root node. And then the next classification of the tree should be based on second highest value of the gain value. Okay, so that is how we are supposed to narrow down. That is how we have to branch out our tree. So I know that you have understood this calculation now, but you won't be able to understand the significance of this calculation until unless you draw two decision trees. And now what are those two decision trees? One decision tree will be based on your this calculation with highest gain value, that would be your root node. Second highest gain value, that would be your first intermediate node, and then so on. And then the second decision tree would be, so did you already calculate Naga for all the four? No. Yes. So as per gain value, first calculate the gain value for all the four, and then try to create one decision tree, and then create one more decision tree randomly without considering the gain values. Okay, so create just two decision trees on pen and paper. You will understand the significance, and then you will cut down some of the branches. If you remember yesterday, we have cut down some branches, right? If both the two branches had the same result, we have cut down that branch, those two branches, remember? Similarly, you have to do it. Again, I am repeating myself. First, calculate the gain values for all the features. Based on those gain values, decide which will be root node, and then apply decision tree. And then second, without considering the gain value, just try to do it the decision tree. You will understand its significance. Okay, with the interest of time, I'm not creating those decision trees, and it will be very difficult to explain it like without drawing. It will be really difficult to imagine. So I would say please draw two decision tree at least, everyone, and then you will understand the significance of this. So can you quickly calculate the gain values? For income, it will be low, high, and medium. Again, this will be divided into three, like this, what we have done here. First of all, did you both understand the calculations what we have done in this slide for age? First, we have calculated the information of output, and then for age, and then gain value of information gain for age with respect to the output. Similarly, we have to do it for income, and then student, and then credit rating. What is entropy? Entropy is a measure of impurity. Simple, right? It is from our thermodynamics definition. Whether you take mechanical definition or data science definition, it is same. Measure of impurity or uncertainty in a bunch of examples, right? And what is information gain? What we are calculating at the end is the gain value or information gain. What is that? It is a measure of how much information a feature gives us about the output or about the class. So to do not lose any information, or I would say decision tree always tries to construct in a way maximizes the information gain, right? It always, decision tree is built in such a way that to maximize the information gain. Why? Because it gives us the information of a feature about the class. So that's a reason why decision tree always try to start with the root node which has highest information gain. That's the whole reason. Okay, so you have constructed the table like this, right? Like what we have done for age, we have to do it for similarly for income also, with low, medium and high. For low, how many positive and negative. For medium, how many positive and negative. For high, how many positive and negative. Okay, I think pen and paper would take lesser time than Excel. So always remember, decision tree is constructed in such a way that it maximizes the information gain. Otherwise, there is no need of this such algorithm if it is not maximizing the information gain. Because if it is maximizing the information gain, then only we can predict our output in a better way. So low has one, we have 4 lows. Okay, 1, 2, okay, yes are 3 and no is 1, correct. For high you are telling we have 2, 2. Okay, let's verify that. Yes, we have 2, 2. For medium we have 2, 3, correct. It's okay, I got it, no problem. So it makes sense. You got the table. Now what we have to do is we have to calculate, because for the output we have already calculated the entropy value or information value, right? Based on the entropy formula. We have to calculate, we are calculating for income. So now let's calculate the information for income for all the three, right? For low, medium and high. So for low, you're telling it is 1. Okay, let's calculate that quickly. It's 1 by 3, 1 by 4 and 3 by 4 with logarithm of 1 by 4 and 3 by 4. Okay, so let's calculate that quickly. 1 by 4, 3 by 4, and then 1 by 4 is 0.25, 3 by 4 is 0.75, and then I'm getting 0.8, no? First of all, for high, which you are getting 2 and 2, right? For that, it should be 1, right? From the previous example, we have already seen that. For 2 and 2, it will be 1. Same value, no? So it should be, for 2 and 2, it should be 1. You don't have to calculate it again, right? For 2 and 3, it would be 0.97. And for 1 and 3, it would be 0.81. Exactly. Because see, for age only, we have calculated 2, 2, right? For age, we have calculated, right? For 2, 2, we have already calculated. For 2, 3 also, we have already calculated. That's the reason I've asked you, it will take only 5 minutes, because we have to calculate only for 1 and 3. No problem, no problem. Right? And then what is the final value then? 4 by 13 into 0.81 plus 4 by 13 into 0 plus 5 by 13 into 0.97. So what is this value? Information of income 0.622. Now Subtract 0.622 from 0.961, you will get 0.34, right? So let's calculate 4 by 13 into 0.81. The next one is 0. Last one would be 5 by 13 into 0.97. 5 by 13 into 0.97. Now I have to give here equal to value, and then I have to add here 0.5 by 13 into 0.97. So it's 0.622. So 0.622 is the correct value, and then information gain value is, information gain for income would be 0.34, right? So what we have seen, the gain value for the income is slightly more. Similarly, we have to calculate for student and credit rating, and then based on this information gain value, you should calculate one decision tree, and one decision tree randomly. You will understand how the decision tree is working at the back end. Okay. Now, the first question, importance of entropy and information gain. So I have already told you what is entropy and what is information gain, and the importance of information gain, and how information is gain calculated. It's based on entropy, right? How decision tree can be used for regression. This I didn't tell you guys. I told you how decision tree can be used for classification, but I didn't tell you for regression. So I want you guys to explore on this, okay? And then create all possible. Here you can make sure that create 2 decision trees. Let me change this. On paper for below data, out of which one should be based on information gain value. Okay, it's the same Excel sheet, same data. Okay, you don't have to worry. You have already calculated for 2 columns. You have to calculate for remaining 2 columns. Now create the decision tree for above data using entropy and information, which I have already given here. So I will remove this question now. It's not required. Okay. Now the fourth question is list down the advantages and disadvantages of decision tree. You must be knowing what is the disadvantage of decision tree now. That it is more prone to underfitting or overfitting? Overfitting, right? So now to overcome this issue of overfitting, which you have asked yesterday, where to stop, how to stop. So for that question, there are different methods to stop this. Okay, there are different methods which you'll be learning in the advanced course. But one such algorithm, which is an extension of decision tree, helps us in resolving the issue of overfitting. So that algorithm is known as random forest. It's a random forest. So this is a single decision tree on the left side, right? On the right side, if you notice, I have 10 decision trees. Okay, so it's simple. When we have a single tree for finding a decision, it is called as decision tree. And then when we have multiple trees, where we will have multiple trees, lot of trees in the forest, and that's the name, forest. So when we have lot of trees, that's called as forest. And why is it random? Because if you notice, different decision trees will give you different output or different predictions. Now how to tell which output or which prediction should be chosen? That's the ultimate goal for us, right? So think in this way. You want to watch, say, one Hollywood movie, and you are asking your friend, how was this movie? If you are asking to a single friend and he asks you certain questions, okay, do you like Hollywood movies? First of all, if you tell yes, he will think in this way. And then he will ask, do you like James Bond? And then he will take a different path again on that. And then he will ask some more questions. Do you like fantasy movies? And then he will take different path. And then at the end, he will tell, then yeah, you might not like this movie, or you might like this movie based on your questions he will be asking you. For example, if you say no, I do not like Hollywood movies, then he will stop at that point itself. If you don't like Hollywood movies, then you will not like this Hollywood movie itself, right? Or he might ask some more additional questions, and based on that, he might tell you, okay, you might like it. It's not a conventional Hollywood movie, you might like it. So, this is a single decision tree. But imagine you have, we generally, what is our human mentality? We will not ask one person, we will ask multiple persons. And why do we ask multiple persons?